Hello everyone, my name is Shrija. I'm from EC department in NIT Andhra Pradesh. My project is on least square method in MATLAB. My guide is Dr. Pulikishore Kumar sir. Thank you for this wonderful opportunity. The objective of this least square method is to use least square method to find best fit line or curve for a set of data points, which involves minimizing the sum of the squares of the difference between the observed values and the values of the dependent variable. The least square method is a mathematical technique used to find the best fit line or curve for a set of data points. In this case, it includes linear regression and nonlinear regression. I took the case of nonlinear regression, where the least square method is used to find the equation of a curve that best fits the data points. This curve can take many different forms, such as quadratic and exponential form. This is the mathematics behind the least square method derivation. After following these all steps, we will be concluding that J transpose J dx is equals to minus J transpose into E of x, where J is the Jacobian matrix and E is error matrix, and we'll be finding dx, and we will be finding new parameters such that x equals to x plus dx. X means new parameter and x naught is old parameter plus dx. Through this we'll finding dx. The flowchart regarding this is: select an initial guess for the unknown parameters, then find the objective function as the sum of the squared residual between the observed data and model predictor. Then compute the Jacobian matrix of partial derivatives of the objective function and find new parameters. Check the convergence of the parameter estimated. If the convergence is met, then we will be ending there. If that is not met, this loop gets continued again and again. Here I took the example of Rosenbrock function. These are the error components in Rosenbrock function. Through implementing this code for this Rosenbrock function, we will be finding the minimum point at 1.001 and 1.001. This is the actual point where the convergence is met in Rosenbrock function. The least square method has many applications in vast domains in engineering, and I took the domain of VLSI. In VLSI too, it has many applications such as curve fitting, parameter extraction, linearity testing, and system identification. Here I took the implementation of VI characteristics curve fitting in MATLAB. First, we need to generate sample data for VI characteristics. I took here V and I. Then define the fitting function. Here we use the exponential function as an example here. Y equals to A into exponential of B into X. Here fit function is defined as in the dependent variable and independent variable x and coefficient. Since this is the symbolic function used to define the c1 c2 x, and we created a vector of coefficient symbols, then define the function. We have computed the Jacobian function through the use of differentiation fit function with respect to coefficient 1 and differentiation of fit function with respect to coefficient 2. Then displayed the Jacobian. We need to define the cost function that to be minimized. The cost function is the here is the sum of the squared errors as an example. Here cost function is defined as sum of fit function of v comma coefficient of with respect to v and coefficient minus I into whole square. Then our initial guess for quotient is defined as 1 comma 1, and maximum number of iterations and tolerance are given. That is, maximum iterations are 100, tolerance is 10 power minus 6. We initialize this iteration counter and the cost. Iteration counter is given as 0 and cost is cost function at the coefficient 0. Then a while loop is created until the iterations are less than maximum iteration. We compute the Jacobian matrix at the coefficient 0, and we will be computing the gradient and Sn matrix through this. Then coefficient is updated with the coefficient 0 plus h, means dx. Here dx is minus h divided by gradient, that is nothing but Jacobian, that error function we have defined. Then again, next we plotted, then we display the new cost function here. If the convergence is met, we will be exited. If the convergence is not met, then the iteration count is incremented and coefficient 0 is defined as coefficient. Then cost is new cost. This while loop gets continued until the iterations are met or convergence is met. Then we print the coefficient 1 and coefficient 2 and number of iterations and print if the convergence is met. Then we plot this in MATLAB. And now I would like to show that MATLAB code to you. This is the same code that I explained to you. So through running this, see the coefficient we got as 0 0.468 0.468619 comma 4.32697, and we got this at ninth iteration, and the final cost is 0.008. See here, final cost is repeated for 3 times, so we have exited here that the convergence is met. And this is the plot of the fitting curve. Results: the least square method can be successfully applied to a real world problem in engineering. The problem involved fitting a non-linear equation to a set of data points, which was achieved by minimizing the sum of the square residuals using the least square method in MATLAB. The least equation accurately represented the data points and was used to make prediction for future data points. Conclusion: least square method is a powerful tool for solving nonlinear equations and is widely used in various fields. It offers advantages such as robustness to noise in data and simplicity of implementation and flexibility in handling various types of nonlinear equations. However, it too has some disadvantages such as sensitivity to initial condition, computational complexity for large scale problems. Here references I took as HC, a discussion on the least square method in the course of error theory and data preprocessing, and the full least squares method in IEEE transaction. These two are very helpful, and the first is really helpful for this project. Thank you, one and all, for your valuable time. Thank you.